Probably some of you had already the chance to hear a little bit about the influence analysis while he was explaining the row sensitivity in his workshop on Thursday. But today, together, we are going to focus on the parts of sensitivity analysis that usually are not very analyzed. And sometimes I think that we don't even have defined clearly when to use, what to use, and for what reasons. We all have seen and used the HP sensitivity, where we change the local priorities of a single entry in the supermatrix. And we have some experience with a simple ANP row sensitivity, where we change all the numerical information for a given node in a way that is consistent with ANP structure. And we recalculate the alternative values. Now, in those cases, especially when you have a well-connected ANP model, like I have in front of me, an ANP model with two criteria, two alternatives, fully connected, everything is connected to everything, you will see that even if we try to apply changes, huge changes to the values, see that at criterion 1 to alternative 1 from 0.25, I'm taking the value up to 0.75. That's not a small change. However, in this kind of fully connected ANP models, the change in the alternative scores is kind of minimal. From 0.559, we go to 0.562. That's not good. That's not exactly what we would like to see. A huge change in the values, I would like to see it reflected in my alternatives. That's why we talk about row sensitivity, first of all, and we'll go more in detail on that. But let's take a look on a very summarized view of row sensitivity. We have the value P that takes values from 0 to 1 and represents the importance of the given node, the node that we are trying to evaluate. P0, which we usually call the fixed point, it's exactly the point that we are going to get back our original values, the values that we get from the synthesis of the model. Pretty often, especially in super decision, you see that by default, the P0 value is 0.5. That doesn't mean that we cannot change it to anything that we would like. Now, in row sensitivity, there are two cases. While the value of P is less than P0, so in my case, less than 0.5, the importance of the node goes down, and the calculation that we do is to multiply the row by P over P0, and then renormalize and synthesize to get the results. While when the P is larger than P0, then the importance of the node goes up, and what we do is to multiply all the rows except the one that corresponds to the node that we are focusing on by 1 minus P over 1 minus P0. And then we are going to renormalize the columns, keeping the ratio. Now, let's see actually the same example, just to realize how different results we get. If I take a 0.1 value for P, which will give me P is less than 0.5, so P over P0 is what I'll use, that gives me 0.2. Small change compared to the change that we did before. However, the alternative scores, say, from 0.55, 0.44, got to be 0.597 and 0.40. So yes, for a small change, I managed to see my model reacting and my alternatives priority changing. That's why I want to use row sensitivity when I am in an ANP model. And the more complex the model, the more collections are in there, the more important becomes to use the row sensitivity. And yes, I can use the row sensitivity even in AHP models, although the HP sensitivity, the single value sensitivity, works fine for HP models. However, it's a really nice way of seeing that, this row sensitivity thing really works. If I change the value of prestige in the I think, famous now sample model for the cars that Super Decision has, we'll see that we can easily calculate with the formula that we just said the new values that the A and P sensitivity give. Now, going to the influence analysis, what is this influence analysis? Well, we use, first of all, influence analysis and A and P round sensitivity on a given node, and then we create a score based on how much the alternative scores change. So how does a node influence the alternative scores? In the same group, we have the marginal analysis. In this case, we focus on the rate of change. So for a small change in the p-value, slightly away from p0, what will cause the largest difference in results? The corresponding pairwise comparisons are extremely important and will affect the result. In other words, with marginal analysis, I can find the important nodes that small changes will end up giving me huge changes in my alternative scores. That is what I was trying to do also with ISAHP. Marginal analysis will give me similar effect. While with perspective analysis, I can find out which nodes cause the most change, so they have the most influence. If this node is really the most important in the model, what would the alternative scores be? So I'm pushing the importance of a specific node to the limit towards 1, and I'm trying to see how that would affect the model. If my criterion 1 was the absolutely most important node in my model, how that would affect the alternatives. How do we calculate the scores when doing influence analysis? We use row sensitivity and move the parameter P to the same lower and upper values for each node. So we create kind of a table over there where we can find out the changing of importance for each node when you change the nodes by the same amount. So when we choose values of P minus, the left side of the range, and P plus close to and equidistant from P0, we can see how much influence the nodes have for smaller changes. And when we choose values of P minus and P plus far from P0, then we can see how much influence the nodes have for large changes.
Dr. Rokou, sorry for the interruption. You have 3 minutes left.
So thank you. How to compare the alternative scores that we get? We can use the taxicab method, the percent change, or the maximum percent change, and the rank change. There are different formulas that we use in different situations. Each of the metrics really is used for something slightly different. So depending on the model, we should get the correct mix of performance measures and find out what is the best option for our model. And here we can see a very simple influence analysis example where we can find out that although A is the one that gives rise to a rank range, the maximum percentage change appears to be the most influential. And similarly, we can do that for the Big Berger model from the sample models, where we find out that only the subs node widely affects the final results for small and large changes. With a marginal analysis, we can find the effect that the node's importance in the model when we change the node's importance slightly. And we can calculate the new alternative scores. And we can do the same for the perspective analysis, where we let the value get very close to 1. And we might find that there are some problems in the calculations there. However, we can algorithmically find out the perspective analysis. So how do we use the 3 methods? Marginal analysis, when we want to do a quick rough estimate pairwise, and then the analysis to find the nodes that are the most sensitive to small changes, and do for those detailed comparisons. The influence analysis, when that is really easy to communicate to the other people, and it moves each node's importance a fixed amount and compares their effect to the results to find out which node affects more the final results. While the perspective analysis really tells us what does the world look like if this node was suddenly the only thing that really mattered. Thank you. Do we have any questions?
I have a question.
Mm-hmm.
Have you published a related paper or planning to publish this as a paper? Is there any? It's very interesting.
We haven't published the paper. We weren't sure that it was innovative enough because it's out there for a long time, being used from some people, but I'm not sure that we have ever, probably Luis, if it was here, or Dr. Lipovetsky, but as far as I know, there wasn't anything published on the influence analysis that is done. Thank you. Any other questions? I apologize. I know that I rushed you through the concepts, but we have a limited time.
How do you use it in practical terms? Suppose there is a big problem. It's hardly possible to try all those variations with one or another element for sensitivity. Is there a way to find some generally more stable solution?
Actually, that's what we have tried to do. We generate for the influence analysis a rewards table that shows the percentage difference for all the nodes in the model. So you can see the percent difference and the rank reversals, if there are, how many rank reversals you will get for specific values. And from experiments, I don't have a proof for that. Usually the values 0.1 and 0.9 and 0.3 and 0.7, the two pairs, give pretty good results. And we have tried to experiment for the influence analysis by not asking the decision makers to do all the pairwise comparison, doing the shortcut, the first line, very simple, very bad shortcut. And after doing the influence analysis, coming back to the decision maker and asking them to fill in only the specific sets that correspond to nodes that will affect the results.
Yes, thank you.
Thank you.